Hi there. So in this clip, we are going to take a look at the different artifacts arising when measuring ECG and a way to minimize them. And we shall do this again with our differential amplifier. So I am going to use Eindhoven 2 today because the angle of the electrical field of my heart is 65 degrees. And this gives us a very strong signal in this lead. So Eindhoven 2. I'll take the positive input and connect it to the left foot. There. The negative input will get connected to the right arm. And ground, or neutral, is always connected to the right foot. There. So you might wonder why I've got two electrodes placed on my wrist. Well, the first one is a new electrode, whereas this one is an old electrode which has dried out. So I'm just curious to see what sort of signal will I get by making this connection. So let's take a look at the monitor. Well, what we get here is a 50 Hz mains, which is actually coming from the power lines in the walls, as well as the electrical fittings, but it is also present in my entire body, as well as in the electrodes. Well now, if these two electrodes were identical, then the signal coming from the positive and the negative input of our differential amplifier would also be identical. You might wonder why I keep saying differential and what that actually means. Well, differential simply means that the amplifier subtracts a signal from the negative input to the positive and eliminates the noise. However, the noise coming from the old electrode, which has dried out, is slightly different to the one coming from the electrode placed on my foot. So the subtraction will not yield 0. Well, let's place this to the new electrode and see what signal do we get from it. So, as we can see, the ECG signal is nice and clear once again. So, apart from really old and dried out electrodes, something else that could get in the way and create a lot of noise in our ECG recording would be artifacts coming from our muscular activity. So let's look at the example of me exercising on a treadmill. And in order to demonstrate this, I have brought along a dumbbell, which is this weight here. And I will just use this arm to lift the weight just a few times and see what do we get on the screen by doing this movement. So very quickly we can see that the ECG is heavily polluted with artifacts. And why would that be the case? Well, at rest, my arm functions as an extension of this cable, and this is convenient for electrode placements. So we simply place the electrode here. But then, when I'm doing this activity, this light exercise, the ECG gets polluted because on its way down to the wrist, it picks up EMG noise from the activity of my biceps. So we have to find a way of getting around this and try to avoid all the noise coming from this area. Well, the simplest way to do this is to simply place an electrode a little bit higher, so not on my wrist, so that we avoid going into this area at all, and just place it higher, say here, closer to the collarbone, as I have done already. And let's see if I connect the negative input here in this electrode. Let's see what signal we get now. So if I start doing any movement here, it doesn't really affect the recording at all because there's no connection down in this area. It all comes down here. And of course, we can do exactly the same with the connections down at my feet. So if I'm doing some exercising using my legs, then obviously I will get EMG noise coming from the muscles in my legs. So what I can simply do is just place an electrode a little bit higher, so somewhere near my waist, as I have here, there, and let's take a look at the monitor. And once again, the signal is nice and clean. So now we have found a way of eliminating noise coming from our muscular movement. But if I start moving my body just a little bit, I see that there are some new artifacts generated on the screen. So where are these artifacts coming from? Well, they're actually coming from cable movement. So even the slightest movement here will affect our recording and will produce some noise. First way, quite easy, is to simply use a shorter cable. So I will disconnect this really long one. You can see here how long this cable is, and the chances of it affecting our recording via its movement are pretty high. And instead I will replace it with this really short one. And get a nice recording without any excessive movement. So another way to deal with this issue is to also find a way of keeping the cables attached closer to the body. And we can do this by either tucking them underneath our clothes or wearing really tight clothes that will keep them nice in place, or using Velcro straps like this one that I have around my waist, or even tapping them directly onto our skin. So now all these methods that we have explored in this clip can be used on all other biosignal recordings as well. And if you wish to find out just a little bit more about the subject, then please visit the video clip regarding EEG artifacts. Thank you.